All right, hey students, so now we're going to cover reflections next. We've covered so far the rotation, we've covered translations, so this is the third one in our set of 4 that we're going to be looking at specifically. So let's get started. So the first thing, as always, I'm going to grab my blue here. Sorry, my pens are kind of all over the place. So I'm going to grab my blue and make my pre-image, of course, right? So let's say I start with a pre-image of A is 1, 1, B is 4, 2, and C is 2, 4, right? And so we need to figure out what my image is going to be. So let's go ahead and figure that out. So we're going to go over 1, up 1. We're going to go over 4, up 2. 1, 2, 3, 4. 1, 2. And then we're going to go over 2, up 4. 1, 2, 1, 2, 3, 4. So there is our happy little triangle. Okay. There we go. And that is going to be A, C, and B. Okay. So, and we want to get the following points. And let's just say we have our image after our translation. So A prime is going to be negative, negative 1, negative 1. B prime is going to be negative 2, negative 4. And C prime is going to be negative 4, negative 2, right? So from there, we are going to reflect it, get the dark green, over into this quadrant, right? Which is obviously everything's negative, so it's in the third quadrant. Well, here's the thing. If we're in the third quadrant, we need to go over a line, a specific line, that line being y equals negative x. Now, if you guys remember from slope-intercept form, when we have y equals negative x, that means we have a slope of negative 1 with no y-intercept. So we're going to reflect it over this line here. It's also going down because it's negative. So our rule for this guy is we reflect, or we have a reflector of y equals negative x. Okay? So we're going to flip him over there. If we do that, we end up at negative 1 for A prime. We end up at negative 2, 4 for B prime. 1, 2, 1, 2, 3, 4. And C prime, we end up negative 4, 2. 1, 2, 3, 4, down 2. So he's right there. And then, of course, if we connect all our points, we get this awesome triangle as such. Now, one thing I want you guys to make a note of here is that if I bumped the camera with the ruler, sorry, if I connect, essentially speaking, let's say C prime to C, right, from here to here. If I connect those 2 points, okay, I connect those points together, what I end up getting is a right angle right here. These lines are perpendicular to each other, which means 2 lines cross each other make themselves a right angle. They cross right here. Now, why is that important? Well, when things are reflected, the points the line C prime will always be perpendicular to whatever your reflecting line is, be y equals x, y equals negative x, or y equals x, or x equals a number. You'll see this in several examples we'll do later on, or also in your homework, but this is how we know that it's correct. If it is not perpendicular, something is wrong. Okay? So a nice little helpful check for you to follow. So let's talk about the algebra. Okay? Now, for algebra, right, we have our original rule, or our original, and we're going to go to our rule. Okay. And for that, we have, of course, the x-axis, the y-axis, the y equals x, and we have y equals negative x, right? Now, something to keep in mind here is that even though there's only 4, we have others that are implied, which is some y or x equaling some number, where you just essentially reflect it over the line. I'll write those rules in at the bottom here, but for now, here are just the general ones. So, are the ones you'll see most commonly. So we have xy, 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 and xy, and that's going to become okay. So for x-axis, what happens is you are going to flip. Oh no, sorry, you're not going to flip. You're going to keep the numbers, the points in the same spot, but you're going to make the back number negative. For y-axis, the front number is negative, stays in the same spots. For y-axis, they flip. And for negative x, y equals negative x, they flip and become negative. Okay, now this is where the whole 180 degree, in the last video that I talked about when I talked about rotations, where I said 180 degrees is the discount reflection, this is why. Notice that it's the same thing, they're both negatives, but they're not the same thing because we're flipping them. So don't mix them up. It's a very common mistake that I see happen all too often. All right, so as far as our other 2 rules that aren't really listed here that are quote-unquote unofficial. So when I say unofficial, what I'm talking about is that whenever we reflect over a number such as x equals 1 or y equals 1, we need to, we're technically not reflecting over an axis, we're reflecting over a line value. Now we'll see that in an example, and I will write a rule here in a minute that will explain that in greater detail that once we go over that example. So descriptions, okay? So for our descriptions, again, I do these in purple. So the first one, x. So for x-axis, the negative y values. Okay, we negative the y values. For the y-axis, we negative the x values. For y equals x, we flip x and y. And for y equals negative x, we negate and flip x and y. Negate is just a fancy word for saying do the inverse. Now, here's the star that's going to talk about what I mentioned earlier with these rules down here and not listing the other ones involving other numbers. So, star. Other vertical / horizontal components okay, so you count the distance. Okay, this is what you do. You count the distance from point to line and mirror to the other side. Simple as that. So if it was an x value, you're going to count off from that x valued line to wherever your nearest point is, and then you're going to do the exact same count to the other side. Keep in mind, this does not mean that you're going to have these off of the x-axis. And again, we'll see that, or off the x or the y-axis in terms of the count. That's different. Okay, that is for the coordinate value, not the count. So we'll talk about that in the examples I'm going to do. And finally, your definitions. Okay. For these guys, we classify this as the flip, real original. Okay. Change in position. There's a change in orientation. And the figures are isometric. Okay, big old star here, which is essentially in the summarization of that is the reverse/mirror images. Okay, so nothing crazy there. Now, in terms of those extra values down here, so what you could essentially write for these formulas is you could essentially write, which there really isn't a formula for it, but the only thing I could think of really is you could do x equals some number, being whatever you reflect by, and then xy would become then the change of those values. So see, that's the reason why we don't really have an algebra statement for it, is because there's not really a way to show that change without using some crazy symbolization that you guys haven't seen yet, mainly involving delta, which just stands for change, and some other craziness. So for now, we're going to go off the description. Okay, so that makes it the end for this video. The next video will have your examples in there. I'll do a few examples of reflections, and then that should help you guys out with your homework and studying. So good luck.